Okay, back to all the graphing. Wait. Or should we start with trig?
No, start right at the start.
Start at the start. Because we started with trig.
Alright, listen, I think we should just start at the start.
Start at the start. Okay. All the graphing. You ready? Okay, so I have a graph, and then I have a bunch of A, B, C, D stuff. Okay, can you write me a coordinate? Can you write me that type of coordinate using that info that you have? By the way, this is a major thing you want to memorize. You better have that memorized. You're going to use that a lot, right? Okay, what do we got? No B. So you should be x plus 3. 2y subtract 1. We good finding the A, B, C, D stuff? Okay, I'm going to grab a few coordinates. So the first coordinate is -3, 1. I'm going to take this one on the y-axis, so 0, 1. 2, -2, and 3, 0. So I took 4 points out of that graph. Okay, we're going to change those 4 coordinates. Okay, what I'm going to do is I'm going to go through all the x's and then all the y's because it'll be faster for my math. Okay, add 3. So 0. Add 3. 3. Add 3. 5. Add 3. 6. Okay. Double the y minus 1. Doubled is 2. 2 minus 1. Okay, that'll also be the same. Double it is -4 minus 1. Doubled is 0 minus 1.
Doubling like dividing?
Double is the times by 2. 0 times 2, 0 minus 1.
So you times the one. You're timesing by 1, right? Like if you times 2 by 1, why? How is it giving you 1?
2 times 1 is 2. Subtract 1 is back to 1. Yeah. Okay. You know what is also a good concept here is to say to yourself, does it match the physical things I thought were going to happen? So if I say that, what are the physical things? Tell me what the 2 should have done. Do you know what the name of that is? Vertical stretch. Did it vertically stretch by 2? Do you see it? Remember what a vertical stretch? It looked like this. Now it looks like this. It's farther apart. Do you see this and this? Do you see this spacing is more? Okay. And then it should move right 3, down 1. Okay. Determine the equation for g of x in terms of f of x. So we started with f and we ended with g. So g of x equals a f of bx plus c plus d. We're going to write that format. G of x is f of x with a bunch of stuff that happened. And now we got to figure it out. Okay. What's your first visual instinct of something that happened to this? It is compressed how? Vertically or horizontally?
Horizontal.
Horizontally. Okay, so here's what I'm going to do. How far apart? What happened there? How far apart are those 2 points? They're 2, and now they're 1 apart. So horizontal compression by 2. I know that'll be a B. So we're going to do that. Ready? This point, -2, would move there. 1, 2, 3, 4 would move here. And then I'm going to take another point, maybe like this one. So that is 6, 2. Okay, I've horizontally compressed it. And what else do we see? Do you visually see something else that might have happened? What do you think? Up 3. And then that should match everything, right? So g of x equals f of 2x and then plus 3.
I am confused.
Well, I horizontally compressed it, so I need a 2 there. And then I moved it up 3, so I need a d of 3.
So, I mean, like, where are you getting the numbers? Are they from the first one?
Well, I took the first one and I squished it in, and I drew it. I drew my green graph is one I squished it in. And then look at my green graph. How do I go from that green to that G? I still have to move it upward. Okay. When you do transformations, does it matter what order I talk about them in? Yes. What would have to come first? Stretches, compressions, and what else? Reflections. Those are all first. And then what would you do after those are done? Then you do the shifts. Up, down, left, right. Okay? Basically, mathematically, what comes first? The AB, multiplier dividers, come before the add subtractors, CDs. Okay, number 3, sketch the graph of its inverse. So here's what's important. You got to understand what inverse means. Or what if I wrote it in symbols? What would it look like in symbols? That and that. Do you understand just what it means when you look at it? So what does the inverse do to a point? An xy becomes a yx. Okay, that's what it does. So you have to memorize the word inverse means that, or the symbols of inverse. Okay, so let's go 1, 2, 3. -3, 2. -1, 4. 1, 4. And 2, 2. Ooh, one of those points is invariant. The 2, 2 is invariant. It's going to also be at 2, 2. So how do I know when something's invariant? You might be asked that. Okay, ready? 2, comma, -3. 4, -1. 4, comma, 1. Now, here's what I always do. I always give this question 2 points. 1, did you get those points? And usually that happens. 2 points, did you connect them together, right? This is where the mistakes happen. How do you connect them together? Do you see where the arrow would go? Do you see it visually?
So basically you're switching them.
I switched them, yeah. There's your shape. And do you remember what it physically does? Do you see it reflecting diagonally?
I really think I see
You don't see the reflection?
diagonal. I feel like it's been flipped to one side.
For instance, this point is
Because of the way they have to look.
do you see that point?
Yeah, I know that.
Is now there.
Yeah.
Look, right? Okay, so I could have just asked this, by the way. This could have been the question. Would you have understood the wording? Sketch the graph reflected over y equals x. I could have asked that in the question. So this is just the tricky part. What does this all mean? Okay? Those 3 ways I could have asked it. Okay, the reciprocal and or the symbol for it. So you need to recognize those words, reciprocal, and you need to understand the abbreviation for it. So an xy point is going to do what? How is it going to change? X comma 1 over y. Okay, so we had a 3-part system here. The first part was a height of 0. What happens at a height of 0? 1 over 0. 1 over 0 is what mathematically? Undefined. So how do you graph the number undefined? An asymptote. So for instance here, this coordinate is 1, 0. So now it's going to turn into the coordinate 1, comma, undefined. So how do you graph undefined? Asymptote. Okay. Then the next thing I do is where is there a height of 1 or -1? Because what happens when you flip 1 over 1? What's 1 over 1? Stays the same. So these points would be invariant. Anytime there's a height of 1, so all of those points and that point, then the third thing I do is analyze close to 0, far from 0. Okay, because if you are close to 0, your reciprocal will be far from 0. If you're far, your reciprocal will be close. Right? The number 50 turns into 1 over 50. So what's going on in this zone right here? What's going on my graph? It's getting closer to 0. So I'm going to go away. Then this section gets close to 0. So it's now going to go away. How would I know when to add a horizontal asymptote yet. What would make me add a horizontal asymptote? Anybody know? What if my graph added this? What's going on? It's going to be going away from 0. So then my reciprocal would go closer to 0. And then what? Now I would need an asymptote. Okay? This one didn't, but chances are you could run into that. If you get anything on your graph that goes away from 0, you now are going to have an asymptote going closer to 0. Okay, the next, what do these symbols mean? The absolute function. So again, making sure you understand what the question is asking. What do those symbols mean? So what do we know? We know the absolute of a positive, it would stay. The absolute of 0, that's the same. And then what do we do with an absolute of a negative? Changes to positive or flips, yep. Okay, there's two things going on here. There's an absolute and there's a down 1. How do I understand what order to do it? Should I absolute and then go down 1, or down 1 and absolute? Absolute first, and then down, yep. Do you know what it would look like in the other way? Versus right? This order would be the opposite way. Okay? So if you would see that, you would have to go down 1 and then absolute. Okay. Ready? I'm going to absolute this. So this first part here is negative. So I'm going to change it to positive. And then this part would stay. Okay, so that's the absolute. Now I'm going to take that and I'm going to shift it all down. So this point, here's all my points shifted down. And that's my final answer. Okay, radicals.
Here's a good question.
Yep.
What if you have the negative f of x in the absolute? Would you attach something anymore? Would you
Like the negative where?
in front of the x?
Like that?
Yeah.
Or like that?
No, inside the absolute.
Inside,
Yeah.
you would reflect it and then absolute it. If you had this, you would absolute it and then reflect it. Yeah. Okay. Identify the x-intercept of this radical. I think we just had this question. Which way have I shifted? Left 5. So that's my x-intercept. Graph it and show me that that's the solution. Okay, so let's show us what this...
Put the 2 there to try and screw with you, or what?
Yeah. It's moved left 5. Now what? Over up. 1, 1, 4, 2, 9, 3. What do you want to do with that 2? What letter is it? A, B, C, D? B. So I'm going to divide by 2. Yep. Okay, I'm going to go a half right, up 1. 2 right, 2 up. 4 and a half right, 3 up. Okay. State the domain and range. 8. Which way is 8? 8 what? Right 8, up 1. There's my starter point. Okay, which direction are we going? We have all these options. Do we go that way, that way, that way, or that way? There's a negative involved. That's a what letter? A. So this is normal. That's the normal one. Which negative do I do to get this one? This would be a negative on the B. If I wanted it to look like this one, what would I do to get it to look like this? A negative A. How would I get it to go left and down? Both negative. Right? Does this make sense? To get it to go down, you change your Y's, which changes A. To get it to move left, that means changing X, which is a B. To get that pattern to go left and down, you're changing both. Okay, so now we've determined that this is the one that we picked, the A. So what is the domain? How do I write that domain? We are 8 to infinity, and the range, negative infinity up to 1. Okay, identify a function. We got to make an equation here. -2, 3. This domain says less than, so we are going to be heading left, and this range says greater than, so we need to head up. Do you know what your radical looks like? Left, up. Okay, which reflection negative is that? A negative on the B. Okay, so I need to write that. I will give you the format. This is the format. Can you write me what you have with your numbers? Okay, rationals, the other thing we just did. Okay, I am, first of all, going to factor the bottom. Multiplies to 4, 4, 1. Adds to -3. Okay, non-permitted values. What do I not want x to ever be? A 4 and a -1. Not allowed.
There is a whole.
So this one gets canceled. So it will be a whole. And then this one will be a asymptote then. Okay, let's talk about our degrees. What do you think? Higher somewhere or the same? Look at the original. What do you have here? An x. Here you have an x squared. So now it's higher. So that means what? Y equals 0. Asymptote. What is my simplified equation after I did that canceled factor? 1 over x plus 1 Okay, so here's what we need to do. We need to do 4 because we need the whole. We need to do 4 because we need the whole. And let's pick 2 on each side of that line. So I'm going to pick x of 0 and 1. I'm going to pick a -2, -3. Okay, are you okay if I do these fast? We're all okay? When I put a 4 in, it's 1/5. 0 is 1, 1 comma a half. -1, -1/2. Okay, so let's go 0 comma 1, 1 comma a half. And I'm also going to do the whole, so 4 comma 1/5. You got the shape? Curves with the asymptotes. Gets lower, lower, lower. And then on the other side, kind of just reflects the corners there.
How do you pick the numbers?
How did I make the numbers?
How do you pick them?
Like this? Or how did I pick? Well, this is -1. So I just go, what's 2 on this side of it? And 2 on that side of it. So -1 here. So I picked 0 and 1. And on this side, I picked -2, -3. Okay. Logs. First question, what's the base? 5. Okay, go. Give me 5 to the 5 to the 5 to the. What do we always start with? -1, 0, 1. Okay, as soon as you do a base, I don't care if it's exponential or logs, just do this. Okay, since this is a log graph, how do I write those two numbers in a coordinate? Which one is first and which one is second? Remember, it's a log, so it goes like that. Output, comma, input kind of idea, right? Okay. Now you go back and think A, B, C, D stuff. This is doing what? It's right one. So all I'm going to do is x plus 1, comma, y. That's what I'm mathematically going to do. 1 1/5. 2 and 6. Okay, do you remember the just general shape and asymptote on a log? Because there's an asymptote. Do you remember how it goes? With logs, do we have them vertically or horizontally? Vertically, normally it's like here, right at 0. And what happened to it? Right 1. If you forget, you probably want to sketch 1 or 2 more points to see what is actually going on more and more. Okay, ready? What's the base? That's the first question. What's the base? 2. Just 2. 2 is the base. Okay? The exponent, if you wanted a base of -2, it would have to look like that. Okay? The exponent is only attached to the 2. This is bed mass, exponent, then it's an afterthought multiply. Okay, so 2. 2 is your base, so do the same thing. Okay, as soon as you identify your base, just do that. How do I write these coordinates because it's exponential? All right, now what is going on? We did this and we did this. What letters, A, B, C, D's, do you see?
B.
A and D. If you want to see a B, do you know what it would look like? That's a B, because it's right in front of the X. Okay, so here's what I'm going to do. I'm going to go nothing to the X, -y plus 2. That's what I'm going to do mathematically. Okay, so I'm going to rewrite all my x's as is. Okay, ready to do our math? -1/2 plus 2 makes 1/2. -1 plus 2 makes 1. -2 plus 2 makes 0. Okay, What do we know about asymptotes on an exponential? Where do they start on exponentials? They start like that. What has gone on here though? Up to. And again, if you're like, I maybe don't quite see it, do a couple more points. So start here and go back, like go 2 to the negative 2, go 2 to the 2, 2 to the 3. Do a few more points then. Okay? So here's a studying tip. Your log basic looks like that. Your exponential basic looks like that. Okay, that's how they normally would look without the transformations on them. Okay, exponential could have gone decreasing if the base was what? Less than 1. Okay, we can do it. One more page of graphing. Oh, speaking of that one, Keegan, there's your answer. Okay, what did I just say about exponentials? How do you make something decrease? The base is less than 1.
How many trick groups are going to be on the exam?
1.
Just one?
I'll talk about it when I get there. Okay. Sketch this graph. Do you remember what sine looks like and cosine looks like?
Oh. I remember.
Sine. What's different about how cosine looks? Starts on the top.
I remember that I just like didn't want to do this test, so I went back like a week.
Okay,
That's all I remember.
I'm going to sketch a cosine curve, and I'm going to put this and this on it, the A and the B. So I'm going to start at the top. Okay, so there's a cosine curve.
I just skipped it.
All right, now 10. What does the 10 do physically to this thing? It's an A, so what does an A do physically? What's the words? Vertically stretches it by 10. There's some vertical stretch, horizontal compression questions on there, so you got to get the words down again. So what's the new heights here? 10 and negative 10. Check. We're done the stretch. All right, next. What do I usually mark right here on a normal cycle? What does it take to end a cycle? 2 pi. Look at you guys go. What do we do mathematically with b's? We divide. Okay, now, how do you like to divide and fractions? What's flip and multiply? And then, what do you notice here? Cancels. And so now, this x value is now 4. Do you think you could come up with x values on these other points for me then? What's this x value, this one, and this one? Oh, I gave you a nice one. Not like random halves and stuff. Okay. We're not done. Now we're going to do a whole nother graph, and we're going to do, ooh, you know what? I kind of want to add something to this. Is this okay? Can I add this to the question? +3, because I think you need to practice all ABCDs. Okay. So I'm going to add that. I'm sorry. Okay. So, ready? If this D is 3, I'm now going to kind of do like a lightly dashed line. So I know that that's the middle of my graph. I'm going to make a mark to show what the highest is. What's the highest now? 13. I'm going to show you a mark for the lowest. What's the lowest now? -7. Whew, we're good. Good job, guys. Now, I'm going to make my marks here. 1, 2, 3, 4. Okay, ready? I'm going to take this point. Where am I drawing that point? It's on the top, and I need to move right 2. So that is that point. Okay, I'm just going to take that one point, and then I'm just going to do the pattern now. I'm not going to take every point individually. Okay, where should I go from the top? Where's my next? The middle. So at 3, I'm hitting the middle. When you get to 4, you should be on a bottom. By the way, what does this say in the question? You have to go from exactly 0 to exactly 6. So we got to keep going. What's going to be at the ends? What's not going to be at the ends? Arrows. You're not going to do arrows. Okay. So now we're at the bottom. At 5, where should I go to? The middle. And at 6, I'm going to go to the top. Okay, do you know how to work backwards yet? How do you go to 1? Where are you going to go to at 1? The middle. And at 0, you're going to be at the bottom. That all come flooding back? Okay, ready? We have a max at 5,300. And a min at 15, 100. I don't know why I drew those axes. I'm just confusing myself. Okay. Ready. This is what it's going to look like. Oh, we have to give a sine and a cosine. So it says that we have to give one of each type. Okay. First question. What height is in the middle of all this? That's my first question. What height is in the middle of that? This is 100 and this is 300. So what's in the middle? 200. Okay, so there's, hey, 1 point. This is worth 4 points. We already got 1 point. 200's in the middle. Next question. How much have I stretched from that middle line? 100. So here's 2 points. That's the stretch. That's the A. Okay, now let's do the B. How much space did I move from there to there? I moved 10. Is that a cycle of time? No. What would I think about when I think, is that a cycle? No, it's a half of it. So it would actually take me 20. 20 to get through a whole high, middle, low, middle, high. It would take me 20 moves. $20 equals 2 pi divided by what? Your period is always 2 pi over b. So I'm going to switch the b and the 20. And then you probably would see me usually reducing it. So pi over 10. Okay, do you notice how everything is the same on both of those equations? The only thing that's going to be different is the starter point. Okay, sine. Where am I going to find a sine starter point? How does sine start? It starts in the middle on its direction up. So is this a sine starter? No, because it's in the middle, but it's heading downward. So I could pick this point. Can you get me an x value on that coordinate? This is 5. This is 15. Okay, well, what's the x value in between here? 10. 5, 10, 15. What's this? 0. So I'm just going to leave this with x. That's it. And how do we start a cosine curve? On the top. So which coordinate can I say starts on the top? This one can be a cosine, and it is located 5 to the right.